Okay, here's some more problems on 6.2. This is number 29, and we have the tangent of 4x plus 2, or the integral, of the tangent of 4x plus 2 dx. And the tangent, that was the one that we have to separate. We don't have an antiderivative for the tangent, so we rewrite this as the sine of 4x plus 2 over the cosine of 4x plus 2 dx. And then I rewrite this so it makes it a little more sense. 1 over the cosine times the sine of 4x plus 2, because I know the derivative of the cosine is negative the sine. So it looks like I've got 1 over u du type of things happening here. So I'm going to let u be the cosine of 4x plus 2. Now again, remember we know that the sine and cosine work well together. They're pretty much close to being the derivatives of each other, or by a minus sign. So that's where you're going to get motivation to set it up like this. So I'll let u equal the cosine of 4x plus 2. So now I've got the integral of 1 over u times this sine of 4x plus 2 dx. And I have to get my u's to match up, so I'm going to take du. So du will equal the derivative of the cosine, and the derivative of the cosine is negative the sine of 4x plus 2, and I have to apply the chain rule, so times the derivative of this, which is going to be what? 4, and I hope you can see this, I kind of ran out of room, but that's dx. So the derivative of the inside is 4 dx. Okay, and I just want sine, I don't want a 4 and I don't want a negative, so I'll divide both sides by negative 4, and I've got du over negative 4 equals now just the sine of 4x plus 2 dx. And now I've got a nice match. That's exactly the same as that. So instead of writing this, I write that. So I've got 1 over u times du over negative 4, and that's the integral. Then I can take out the negative 4 as negative 1/4, or the negative 4 in the denominator as negative 1/4 in the front, times the integral of 1 over u du, and that's just like page 332. We know that that's going to end up being, this will end up being the natural log of the absolute value of u plus c, and I've got a negative 1/4 in front. But what was u? U was the cosine of 4x plus 2, so instead of writing u here, I write the cosine of 4x plus 2. Everything else stays the same, and I'm done. So look that over. You can pause it, take a look at it, make sure it all makes sense, and you thoroughly digest everything we're going through. Okay, number 31 is a lot easier. Have a nice easy one here. This is just the cosine of 3z plus 4dz, and we know we have a formula for the antiderivative of the cosine of u du. It's just the sine. So we're going to let u be 3z plus 4. So now I've got the cosine of u dz, but I have to have this in du. So I've got du equals 3dz, because the derivative of this is du, and the derivative of 3z plus 4, derivative of 4 is 0, and that's just going to be 3dz. But I just want dz, so I'll divide both sides by 3, so I have dz equals du over 3, so there's my dz's. So instead of writing dz, I write du over 3, and I've got everything in terms of u, except I can take this 3 out as 1/3, and I'm set. This looks just like on page 392. The integral of the cosine of u du is the sine of u plus c. And we have a 1/3 in front, and then we just resubstitute. What is u? 3z plus 4, so I've got 1/3 sine of 3z plus 4 plus c.